SmartPot.
Innovate the green. General structure.
Overall view of our project.
We can divide the microservices that make up the system's architecture in three main subgroups. First, we have the device connector, which is made up of the plant character and the sensor actor. There is an MQTT client that listens to some specific control MQTT packets and responds by activating one of the two SmartPots appliances, which are either a water pump or a LED light. We then have the sensors actor, which is also an MQTT client that publishes data directly to it from the SmartPot's temperature, humidity, light, and soil sensor. We then have the microservices grouped under user interaction. These are actors that directly process user requests which are submitted through the user interface. Mode Manager is the microservice that keeps track of the plant's modes and also handles all requests that enable or disable set modes. It receives commands from the UI through its REST interface, and it also communicates with the other microservices that handle the various modes through their REST interface, so by sending REST requests. It also has the function to store the schedule, the schedules which are used by the preset mode. Manual mode is the user interface that allows the user to directly control the SmartPot's appliances. It exposes also a REST interface through which the user can directly send commands which are then translated into MQTT commands sent directly to the plant character. Finally, we have the third-party adapter. This is a simple MQTT client that listens to sensor data published by the sensors actor and sends it through the REST interface to ThingSpeak, which is a third-party platform that allows to visualize this data. The last group is automatic control. These are actors that also control the SmartPots appliances, but do so without direct user intervention. Preset mode will publish MQTT commands to the plant care actor according to a schedule that is retrieved from Mode Manager through a REST request, and it also exposes a REST request allowing Mode Manager to change this schedule during the system operation, so in real time. Fitment mode acts in a more autonomous manner. It sends MQTT command to keep it attempting to keep its humidity level above a given threshold. It will also monitor the amount of light a plant is received during the day, and when night comes, it will decide to supplement the plant with additional light if there is a light deficit. This actor has an MQTT client that allows it to listen to sensor data from humidity and light sensors, and it also exposes a REST interface allowing Mode Manager to change the value of the thresholds and the illumination time during the system operation. Finally, we have the home catalog and the user interface. The home catalog is an actor that stores the URLs of all microservices in the system as well as the topics of all active SmartPots. All microservices upon startup will request this information through the catalog REST interface. The user interface, which is built on Angular 11, allows the user access to all of the system's functionalities. The user actions in the interface are translated into REST requests, which are sent to the Mode Manager or the manual mode if it is trying to control directly a plant appliance.
User interface.
It explains how user can control and monitor the plant.
You can see in our website now, there is a list of plants in the main page. So this list of plants is got by API of Home Catalog. And we can also add plant in here in the list with the help of Home Catalog. So we can add any plant with the name. So it's added, and we can enter this plant and we can delete it with the help of Home Catalog in here also. Nothing is done yet with the modes of them, so we can delete it now, and we can go to any of these plants in order to control them. So we will go to the first plant in Basil. Here we can see in the dashboard the data which is got from the sensors with the help of ThingSpeak. It's shown, so you can see it here. Then we can control the modes. We can switch on, switch off them with the API of mode control. So I can switch on or switch off any of these. For example, here, as you can see, it's switch on and switch off. It works with the API of Mode Manager. And in here, there is, if you give attention, like some submit buttons that works like that. So in each of them works with the API of each mode. For example, if we control water or light with start and stop button, it works with the API of manual mode. It connects to the manual mode microservice and works with them. Or if we give schedule for automatic mode, it connects to the automatic mode microservice and interacts with them.
ThingSpeak.
Visualization of data coming from sensors.
ThingSpeak. We use ThingSpeak to store data coming from the SmartPods sensors, and we use it also to visualize that data. So we have 4 different sensors: lighting, temperature, water tank, capacity, and soil sensor, which is the humidity sensor. How does it work? We create, as you can see here, a ThingSpeak channel for each sensor. Then we have the ThingSpeak adapter actor, which is an MQTT client that listens to the sensor data which is published through MQTT and forwards it to this ThingSpeak channel using the ThingSpeak REST interface. So you can see from here we have different channels. This one has the readings for the lighting, this one has the reading for the temperature, and so on and so forth.
Hardware.
List of hardware devices used in SmartPod.
Hardware of our project consists of Raspberry Pi, Arduino, 4 kinds of sensors, relay, water pump, and LED diode. So there are sensors. This one is soil moisture sensor. This is light presence sensor. This one measures water level in water tank, and this one measures temperature around the plant. So in this slide we can see wiring of our hardware. So these 3 sensors are analog sensors, and this one is digital sensor. All analog sensors are connected to Arduino. And Arduino measures sensors data and calculates average, and then sends to Raspberry via USB port. So on the Raspberry runs 6 microservices, 4 of them for sensors, 2 of them for controlling relay. And all microservices receive this configuration from Home Catalog and connect to MQTT broker. So, 4 services for each sensor works independently and listens data from Arduino and publishes this data to specific topics on every 30 seconds. And other to microservices also works independently and subscribed to specific topics related to plant. And they also connected to MQTT broker. When this two microservice receives data from MQTT, they will send command to relays to switch on the motor or to switch on the light. So this is Raspberry, and here we can see 6 microservices. This true one is true microservices for controlling light and water pump, and this for one is publishing sensors data.
Main page.
In the main page, you can see all plants that is under control.
Here we can see the real-time demonstration case of our project, SmartPod project. So first of all, as you here can see, our plant is already equipped with our sensors and with our motors and with electronic devices. So first of all, in order to control the SmartPod, we will go to our website. Here is our website. So in this website, as we can see, there are several plants. Our project consists of several plants, but our plant, the Basilica, is here on the first plant. So we will go to the first plant in order to test, in order to show demonstration. So first of all, our project shows dashboard. So in dashboard there are the real-time measurements by our sensors in the last hour.
Manual control mode.
In this mode, you can control everything manually.
So there are 3 types of controllers, as you know, in our project. So we will go to the first one, manual one, and we are going to test the manual control. In manual control, you can switch on manual control if the feedback control is switched off. So we can switch it on, no problem. Then we're gonna test our manual control. If we want to run the water or light and unlimited and stop manually, we do not give any input to our input tag. So let's test it. We're gonna start. Water is running and we're gonna stop. Water is stopped. And same works for light. We didn't give any value, so we're gonna start. Light is on, so it doesn't stop until we stop it manually. So we can stop. Like that it works. So you can ask, what about if we enter some value in here? So we can enter 2 seconds to watering. I can click on the start button. So in 2 seconds it worked and it flows the water inside our plant. And we can also test the light in the same way. So we can give like 5 seconds in order to test our light. Let's start. So for 5 seconds our light is on and it's off when the time finishes. So this is how manual mode works.
Automatic control.
In this mode, our system takes care about your plant.
In automatic mode, so we can control it by giving the schedule and with clicking on. So we switched on the automatic control, and right now we can give some kind of time, and in this time that our device works. So let's start with water again, and it's time of 13:25 as we see here. So we're gonna give 13:26 maybe in order to test, and another test like 13:27. So duration is 1 second, and so let's go. I submitted. So it's Sunday, by the way, it's switched on already. Here we can see, as we have showed, that system works for 1 second. The water flows into our plant, and after again 1 minute, the second time that we entered is gonna work. So it worked. This is how the automatic control works with some schedule that we enter. So why not we try the light for scheduling? Let's give a time for this one also. That's 28, and we're gonna switch it on for 10 seconds. So we can submit it. And our light is on. So it's going to be on for next 10 seconds. And if you want to enter more than one time for the day, you can use these buttons. So this is all for automatic control.
Feedback control.
So we came to the feedback control mode of our project. First of all, in order to switch on the feedback mode, we should switch off the automatic or manual mode. We want to try it on, like switch it on. Our project gives an error, and it suggests us to switch off manual and automatic control mode. So we can go there and switch off them. Then we can come back and switch feedback control mode on. So in feedback control, how it works? Feedback control takes measurements data from our sensors, and in the backend part of our project, it works from the system that we enter, from the threshold that we enter. It controls from there. So let's imagine that we have entered some threshold, and it checks this threshold with the actual sensor data, which is shown. You can see in here dashboard. So it compares them with real data, and if it needs to increase, for example, the humidity, so it will add more water like that. So let's further test. We should see the humidity. Humidity is showing 672 right now. So in our case, let's it increase to the around 700. So if we give this threshold for the water, at every 30 seconds it gives water for some time, and until it reaches this humidity threshold. When it reaches this humidity threshold, it will stop watering our plant. So let's test it. So here we gave humidity threshold around 700. As you see, water is running and it continues such flow until the humidity increases to 700. And we can work with the light mode. There is two inputs. There is light time and there is illumination threshold. The light time means like we can in how many hours or in how many seconds our plant should be lighted on, like the light has to be given at that time. So illumination threshold is controls light if the given input is at night or at daytime. So if we give like 480, the illumination, the sensor data is less than this input data, our project takes it as it's not taking light, so it's a night. For the test, we're gonna give at 2:31 in backend, 2:31 p.m. as a night time. So night starts at 2:31, and the system, if for example we're gonna give 36,000 seconds, so it means 10 hours. 10 hours, our system gonna take need to take light. We can give it like that, sorry. In lightning, we can see it's 369 or 370 around. So we're gonna give, see, 300, let's take 400, and we're gonna submit it. So at 2:31, so our light is on at 2:31 p.m. And it takes, like, it keeps the light on until it reaches 10 hours light time. For example, it has been lighted on 8 hours, so the 2 hours our light is going to keep switch on. That's all for the demonstration part of our SmartPod project.